So, hello everyone, welcome to our Ask Geology, a whole new way to understand our Mother Earth. So, in this today's 7-minute numerical, we will be discussing one structural geology question, and that is based on Anderson theory of faulting. You can consider it to be in the domain of structural geology as well as engineering geology, because in engineering geology we also used to study about the engineering properties of rocks. Okay, so these parameters can be considered on the domain of structural geology. So the question is, the tip line of an actively propagating thrust fault is located at a depth of 1 kilometer from the horizontal ground surface. First thing, just take out what are the information. This is basically a thrust fault, which is present at a depth of 1 kilometer from the horizontal ground surface, and the average density of the material from the ground surface to this depth is assumed to be uniform and can be taken as 2700 kg per meter cube. Okay, and the rock at this depth follows the failure criteria by the equation sigma 1 is equal to 10 ma plus of 3 sigma 3, where sigma 1 and sigma 3 are the maximum and minimum principal stresses. And here we have to considering Anderson theory of faulting, the calculated maximum principal stress at this depth will be what amount of megapascal. So simply I just decode whatever it is written. Just this is the verbal thing. Now just take it to the pictorial representation. It is saying that it is a ground surface, horizontal ground surface. This is basically the horizontal ground surface at a depth of 1 kilometer. Okay, at a depth of 1 kilometer from the surface of Earth, there is happening something. Okay, there presents a thrust fault. Thrust fault in the sense, this is one thrust fault is present here. Okay, thrust fault is present here. That means one block is moving over another. Okay, now this one block is moving over another. This is the thrusting is happening. Okay, now they are telling what is the density. This overburden, what is the density? This is density is 2700 kg per meter cube. Okay, this is the density of the overburden. And now they are saying this faulting criteria. Okay, this faulting, this is just following the equation. The failure criteria is also following the equation sigma 1 is equal to 10 MPa plus of 3 sigma 3. Okay, this is basically 10 MPa 3 sigma 3, where the sigma 1 is the maximum principal stress and sigma 3 is the minimum principal stress. All of you know this sigma 1, sigma 3. We are considering planar, that's why sigma 2 is considered to be 0. Sigma 1 and sigma 3, these are principal stresses. Okay, all of you know what is the difference between stress and force. Okay, force, the unit is Newton, stress Newton per meter square. Force per unit area, that is called your stress. And a tau, this is the shear stress. Okay, in Mohr failure criteria, all of you know how these equations are happening. Okay, so I'm not going to deduce these things, but this failure which is happening at a depth of 1 kilometer below the surface of Earth is following this equation. Okay, this failure criteria is following this one. Now he is asking, considering Anderson theory of faulting, the calculated maximum principal stress at this depth. The maximum principal stress, this sigma 1 is the maximum principal stress, sigma 3 is the minimum principal stress. Now he is asking about what is the magnitude of this maximum principal stress which is acting or which is responsible for the faulting which is happening below 1 kilometer of depth. Okay, from the surface of Earth. It is one thrust fault. All of you know, when it is actually a thrust fault, what is the orientation of sigma 1 and sigma 2, or sigma 1 and sigma 3? Okay, sigma 1 should be horizontal, because sigma 1 is considered to be the maximum principal stress, or it has a greater magnitude. It will only take one block off when the magnitude is more. Okay, so sigma 1 is horizontal and sigma 3 is your vertical. This is the orientation, this is the principal stress orientation for a thrust fault to occur or thrust fault to happen. Okay, now this it is following this failure criteria is following this equation. That means sigma 1 we have to calculate 10 MPa, it is given 3, and we have to calculate the sigma 3. What is this sigma 3? Sigma 3 is nothing, this is the horizontal stress, or sorry, this is the vertical stress. Vertical stress. Vertical stress. Now this vertical stress is caused due to the overburden. Okay, so it is basically simple. The pressure P is equal to rho GH. This amount of pressure is being exerted from the top part, or this is the magnitude of sigma 3 which is acting upon these things. Okay, and sigma 3 is the minimum, sigma 1 is still more than that. That's why it is creating a thrust fault over here, isn't it? So what is the sigma 3? This pressure, this is your sigma 3. Then just calculate what is sigma 3. So sigma 3 is equal to, what is rho? This is given 2700 kg. Let's just unit kg per meter cube. Okay, what is g? G is given to be 10 meter per second square, 10 into meter per second square. And what is h? H is 1 kilometer, that is 1000 meter. Okay, this is the unit. You just simplify, the unit will be meter will cancel out, so this is kg per meter into second square, which is nothing but this is your Newton per meter square. Okay, so what is the calculation? 2700 and 10 and 10, this is 27 into, this is 3 4 5 6, 27 into 10 to the power 6 Newton per meter square, that is your Pascal. Okay, so it is equal to 27 MPa, 27 megapascal. So what is the magnitude of sigma 3? This sigma 3 is nothing but the vertical stress acting on this orientation, and it has a magnitude of 27 MPa. And now finally the failure criteria, it is following what equation? The equation is given sigma 1 is equal to 10 MPa plus of 3 sigma 3. So this 10 MPa, this is 10, okay, plus of 3, what is the value of sigma 3? We just calculate 27. This is also in megapascal, this is also in megapascal, so unit is MPa, no doubt. So this is 10 plus of 27 cross of 3, this is 81, so answer is 91 MPa. So what does this mean? This is telling that the sigma 1, okay, which is acting horizontal, because for the formation of thrust fault you need, what do you need? You need the sigma 1 to be horizontal, and vertical is the sigma 3. Sigma 3, how, what is that sigma 3? Sigma 3 is nothing but the stress which is acting due to the presence of the overburden. So it is nothing but simply the pressure. Okay, now pressure is calculated depending on P is equal to rho gh. Okay, now this rho gh value we calculated to be 27 megapascal, and this faulting which is happening, or this thrust fault which is happening at 1 kilometer depth below the surface of earth, it is following this criteria. This is the failure criteria. So if we just put the sigma 3 value here, we will be able to find out the sigma 1, and that is what it is asking in this question. So our answer will be 91. So another thing, be very much careful about the units. Okay, whether it is mega, giga, and these conversions. So I think this much explanation is also very good, and you can join us. Okay, you can join us, you can just go to our website, YouTube about, there you can find all the social media platform, you can just join. Okay, and there is also our in Play Store, our application is also available. You can find, this is basically the logo for our application, so you can just go and download and join. join our group. So thank you very much. And if you're interested to join our group, then you can directly contact to these numbers and put a mail to these numbers. And I wish you all the very best of luck for the upcoming exams, and all the best, and all the very best of luck to everyone. Thank you.